So hello everyone, today I'm going to do the video exercise for 3.9 number 16. So just as the beginning, I'll just read out the question from the textbook. So the question is, at noon, ship A is 150 kilometers west of ship B, and ship A is sailing east at 35 kilometers per hour, and ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? Alright, so how you would want to approach this question, ideally, is by drawing figures, and that's exactly what I'm going to do. So initially, what you want to do is, at 12 p.m., you write the position, you would draw the position of each of the ships. So you would know that ship A, and the distance between ship A and ship B is exactly 150 kilometers. As I write, ship B. So the distance between here is 150 kilometers. So then what you want to do is that you would want to find out where the ships would be at 4 p.m. So at 4 p.m., ship A, which was initially here, A would be somewhere around here, and ship B, which was originally here, would go somewhere around here, and this is where it was. And I'm just putting this like mark here just to show like how much it traveled. So we know that the distance between this whole thing was 150, and we know that ship A has to travel 35 kilometers per hour east, and B travels 25 kilometers per hour north. And you can find out how to calculate the distance by the rate and like the amount of hours. So the amount of hours you have between 12 p.m. to 4 p.m. is 4 hours. So the time is 4 hours. And you know that ship A has like a speed of 35 kilometers per hour. So speed is going to equal 35 kilometers per hour. So, and you also know that distance is equal to speed multiplied by the time. So distance is equal to 35 times 4. The distance is equal to 140 kilometers. So ship A has traveled so far 140 kilometers towards the original place of B. So now you know that the total distance between ship A and ship B originally was 150, and after 4 hours, ship A has traveled a total of 140 kilometers. That leaves 10 kilometers from the distance from the origin of B. So that leaves us 10 kilometers. So now we can go to ship B. So ship B would do the same exact thing. The time between 12 to 4 was 4 hours, and the speed was 25 kilometers per hour north. So distance is equal to speed multiplied by time. So distance is equal to 25 multiplied by 4. Distance is equal to 100 kilometers. So ship B has traveled 100 kilometers north of exactly where it had started. So with this whole new information, we can now create a new triangle which can help us solve the question. So the new triangle would be ship A, which is 10 kilometers, which has 10 more kilometers to go, and ship B, which has traveled 100 kilometers. And what we can do is find the hypotenuse by using the Pythagorean theorem. So r squared is equal to x squared plus y squared. R squared is equal to 10 squared plus 100 squared, and r squared is equal to 100 plus 10,000, and r is equal to the square root of 100 plus 10,000, and r will eventually just come up to be 100.499 kilometers. There you go. After that, we can now derive the equation that we use to find the r. So basically, you derive the Pythagorean theorem. So if I were to just take these two, so r squared is equal to x squared plus y squared. So if I were to derive it, it's going to be equal to 2r dr over dt plus, is equal to 2x dx over dt plus 2y dy over dt. Now we can actually plug in the values. So we know that the 2 stays there, it doesn't move, and we know the r, which is the value of 100.499 kilometers, but we do not know the rate that it's traveling. That we don't know like dr over dt, and that's exactly what we're trying to find out. So 2 times 100.499 dr over dt is equal to 2 times x, which we know is 10. This is x, which is 10, and that is 100, which is we know that x is 10, and we know what the rate it's traveling at. So dx over dt, we know that the ship A was initially traveling at a rate of 35 kilometers per hour. But mind that we would actually take the rate to be a negative, because the distance is decreasing as it moves to the west. Because as you can see in this, I don't know if you can see, just hold on, let me just put it down real quick. If you can see here, the ship A is going towards this side, and as it keeps moving, it's decreasing. So that means that we put the rate as negative. So 2 times 10 times negative 35 plus 2 times 100 times 25. And notice that I did not put a negative sign in front of the 25 because B is increasing and it's going to the positive direction, so there's no reason for me to put a negative sign. So if I were to do the math real quick, 2 times 10 times negative 35 is going to be negative 700 plus 5,000. And I got that 5,000 by 2 multiplied by 100 multiplied by 25, and it would give me 200.998 multiplied by dr over dt, and I got that 200.998 by 2 multiplied by 100.499. That's where I got it from. So with this simple equation, now I can finally isolate for dr over dt. So so dr over dt is equal to negative 700 plus 5,000. So that would give me 4,300. And I would now divide it by this whole thing. So divided by what was on the left side initially. So I would divide 4,300 by 200.998. And that would give me the distance between the ship changing and the rate. So that would give me the rate. So if I would do the math in the calculator, I would get dr over dt is equal to 21.39 kilometers per hour. And that is the final answer for the question. Yay. So therefore, let me just write it therefore, a statement. Therefore, the distance between the ships it changes at a rate of 21.39 kilometer per hour at 4 p.m. And that is the final answer. Thank you for watching. Yay!